Hello everyone. So I thought it'd be a good idea to go through a geometrical proof question. So this particular question is from one of the Edexcel papers. I believe it's Mock Set 2, paper 1. So if we read the question first, so we're told that we have this diagram of a quadrilateral, X, B, Y, A. We're not told whether it's a, whether it's a square, a rectangle, a trapezium. It's just a generic quadrilateral. We're told that the diagonals A to B and X to Y intersect at this point M. And we're also told that the areas of triangle AXB, so that's this one that I'm highlighting over here, is equal to the area of triangle AYB, which is this triangle over here. Right, we're asked to show that the diagonals X to Y and A to B bisect each other. Right, so bisect means to cut into two equal parts. So really, what we're asked to show, and I'll write it down, is that X to M and M to Y are the same. Right, so if I write that down here so that you have an idea of what it is we're trying to do. So we need to show that X to M is equal to M to Y. The fact that these two triangles, so this one over here and this one over here, have the same area is actually really useful. Right, now what I'm going to do is I'm going to drop a perpendicular line down from here to here. I'm going to call this point C, right? And hopefully you can see that we now have a right angle triangle. I'm going to draw another perpendicular line from X down here. That's a right angle. The reason I'm doing that, and I'll call this point, what should we call this? We'll call this D. If you look at these two triangles that I've got drawn here, so this right angle triangle over here, so that's CYM, this triangle XDM, C to Y in this first triangle is going to be the exact same length as D to X. How do I know that? Well, I've used the fact that this triangle over here and this triangle over here, right? They have the exact same area, right? So I'll put my reason in brackets, and if you're doing a question like this, make sure you put your reason down as well. So we'll say that the area of triangle AXB is equal to the area of triangle AYB. And notice both of those triangles have the same base. Right? So we'll say here, and both triangles have the same base, which is AB. Right? So if they have the same area and they have the same base, it means that their perpendicular heights must also be the same. So that's why I said C to Y must be the same as D to X. Right, so I'll put that down here. So the perpendicular heights must be the same. Remember our goal? We're trying to show that X to M is the same as M to Y. Okay, now the next thing I'm going to do in these triangles that I've drawn here, so triangle CMY, I'm going to label this angle, which is angle CMY. So this angle over here, I'm going to call that theta. I don't know its exact value, but I'm going to call it theta. And in the other triangle, so triangle XDM, I will call this angle theta as well. So in other words, they are both equal. What I'm saying is angle CMY is equal to angle XMD. They're both equal to theta. Why are they both equal? Well, because they're vertically opposite angles, right? Because we have two intersecting lines over here, so it means that this angle must be the same as this angle. They're vertically opposite angles. Again, make sure you put that reason down. So we'll say they are vertically opposite angles are equal. I'm just going to draw those triangles out separately. So if you see here, right, so this first triangle is triangle CMY. That's my right angle over here. This is the angle that I called theta. Right, now, using a bit of right angle trig, if you remember that the sine of an angle is the ratio of the opposite side to the hypotenuse. Right, so we can say that the sine of this particular angle theta is equal to cy, that's your opposite side, divided by the hypotenuse, which is my. And in the other triangle, so that top one, xdm, let's draw that one out. It's not a very good triangle, is it? Let's drop that line down a little bit. Okay, well, clearly I don't know how to draw a triangle with this thing, so we'll just leave it, pretend that I've got a very lovely drawn triangle. This was my theta, right? So this was point X, this was point D, and this was point M. Okay, in this triangle, if I work out the sine of that angle theta, so remember it's the ratio of the opposite side to the hypotenuse. So look, opposite that, we have D to X, and the hypotenuse is M to X, right? Or, you know, you can say X to M if you want. So in fact, let me just do that. You'll see why in a second. So I've got sine theta from this triangle. I have sine theta from this triangle. Both of those should equal each other because they're both sine theta. So I can say that C to Y all over M to Y should equal D to X all over X to M, right? Because they're both equal to sine theta. But we already know from the very beginning that C to Y and D to X are exactly the same thing, right? So C to Y, D to X, they're exactly the same thing. Because the numerators are exactly the same, it must mean that the denominators are exactly the same. So M to Y must be the same as X to M. I'll write that down over here. But we know that C to Y is equal to D to X, and so M to Y must equal to X to M. Right, because remember over here, just to recap over here, we said that those two sides were the same, right? So if the numerators are the same, then the denominators must be the same too, right? So we've just proved that X to Y does bisect A to B. And also on a side note, just these two triangles are congruent triangles by AAS, right? Two angles, side, two angles, side. If you found this video useful, please like and subscribe, or click somewhere here to watch another video.